Okay, logic gates part 2. Gates can be combined to make more sophisticated Boolean expressions. For example, if I do an OR gate here, a NOT gate here, combine them to go into an AND gate. So OR, NOT, and AND. An OR gate has two inputs, A, B, and a NOT gate has one input, C. And they both join into the AND gate here, and the output to the Z gate. Not the Z gate, so Z output. And how do you write this as a Boolean expression? Z equals A or B. Then it's AND. I'll put these brackets around it so we keep that separate. And not C. Yeah, we've got a bracket here, so if we wanted to. And then we've combined 3 gates. Now, okay, so drawing a truth table for this, we need to work out the variables A, B, C, A, B, C, the inputs, and the output Z. Now we've got 3 inputs, so we can work out 2 to the power of 3. Depending on how many inputs, you do 2 to the power of 3, so that will be 8 possible combinations. For example, to work out every possible combination, the method I use is the half method. So it's 8 possible combinations. All right, 4 zeros, 4 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, 0 1, 0 1, 0 1, 0 1. Split it into 2, split it into 2, split it into 2. Then we can work out all the outputs. If it's 0 0 here, OR gate would be 0, NOT gate would turn to 1, AND gate both need to be 1 for an ON, so this would be 0. 0 0 1, 0 0 1. That still be 0, that will convert it to 1. Now 1 will be going to 0. 2 zeros will equal 0. 0 1 0. So we can see the 0 here would convert into 1. 0 1 would be 1, so 1 1 would make 1. 0 1 1. 0 1 would be a 1 here, and then here a 1 and C converted to 0 will equal 0 at the end, because we need 2 1s to make a thing. Carry on going. 1 0 here will be 1, 0 here converted to a 1 equals a 1 overall. 1 0 will be 1, then the 1 here converted would be 0, so 0 1 equals 0, 1 1 would be 1, 0 here will be 1, 1 1 equals 1, 1 1 1, so 1 and a 1 will equal 1, 1 here converted will be 0, 1 0 will equal 0. And then we have now completed the truth table, and we've converted 3 gates, combined it together, and we've written a Boolean expression for it, and we've done a truth table for it.